Okay, let's go. More C++. Clicked the wrong thing. Great. Okay. All right, so I'm not going to do this 15 minutes of new shit, 15-minute quiz thing. It's not possible to quiz myself on only 15 minutes of this and get answers to it in 15 minutes. That's only enough time to cover maybe the main meat from probably one chapter-ish, the different things you learn in it. I can probably cover that in 15 minutes. But that would be me answering it. The time to check my answers and whatnot would take even more. Now we're up to 45 minutes. I would rather just say, hey, I can probably cover this much and get answers for it in an hour and a half. So maybe, I don't know, once every 2 weeks, I'll do an hour-long test, something like that, just to keep the knowledge going in my head. So it's still a lot better than school because you only have a couple tests a year. So it'll be closer to like middle school, high school, where you have tests more frequently, still even more frequently than that. So we'll say every 2 weeks. So we'll say next week I'll do an hour and a half quiz on this, and I'll do it on a weekend. Okay, so instead I'm just going to do 30 minutes of new material. So I'm just going to continue where we were on lambdas. Okay. So in this case we had different versions, not overloads because they have separate identifiers, because we have a lambda, and the point is that we want to create functions that can take a lambda, and we can pass the lambda to, so we can't make all four of them overloads because then we get an ambiguous match because all four can accept it. But we can make them 1, 2, 3, and 4 separate identifiers and then call them and see how that works. So let's see. So in case 1, we have standard function, and standard function needs to know, allegedly, well, yeah, I guess it's a class template. So we have to pass it the type that the function's returning and the type of argument that the function takes. In our case, it's a lambda that takes an int parameter and then returns nothing. So here's our lambda. It takes an int parameter and it returns nothing. We can tell because auto, there's nothing being returned here. So auto is deduced to be void because there's no value that's being returned. So cool. We can use the function type like this, but specifically a standard function. We could also use the actual function type. So a pointer named function to a void returning function that takes an integer parameter. Well, it's basically the same shit. I almost prefer that to standard function just because it's more explicit and it's one less thing that I have to include, standard functional. It's in standard, so yeah, and you can see it right there. And then we also have templates, and then we also have automatic, shorthand, what do we call it? What's the word? I'm not looking at the screen. Fuck. Is it shorthand? Is it automatic type? What do we call it? It's a shorthand function template. It's abbreviated. There's the word. So, okay, we can explicitly say, hey, there's this type. There's a type of type, right? An object, there's a type name called T, and it can be any type that we receive. So in this case, we're receiving an integer. Why are we receiving two things here? Oh, because we just happen to want to do it multiple times. So, okay, I'll ignore this first part. So we say, okay, we're accepting some type and a reference to it, and the type is const. We're treating it as unchangeable, or like as not being able to change what we're looking at. We can't change the lambda, so cool. Especially, the lambda is named here, so it's an L value. Yeah, interesting, because this is actually, I guess this is kind of a pointer to a temporary function that exists in static memory, I'm guessing. It's probably in the stack. Okay, and we get a reference to it. Also, we could do the same thing with a const auto reference that just deduces whatever the actual type is. So cool. Oh, let's do a timer. Cool. The lambda has to be implicitly converted every time we call it. So call it, call repeat 1, and it has to convert it into the standard function type. So it seems like there's probably a class called standard function, and it holds the pointer. It's probably something like a standard array, where a standard array actually just holds a C-style array underneath. In this case, it's a standard function that holds a pointer to that function type we're doing. I don't think this is any more convenient than any of these other options, so I'd honestly prefer them. That way we don't have to convert to the standard function type. Benefit of being separated to a declaration and a definition. And the point is that that's not possible here. I mean, that's true for 4 too, right? Pretty sure that's true for 4 as well. This is almost the abbreviated version of this. But these are not, this is not a template, so it is not required to be defined in the same translation unit that it is used. So we can put it in a header file as a prototype for declaration, and then have it defined elsewhere like this, and then use it wherever by including that header file. Same here. It's repeat forward. It takes a pointer to a function. It's void returning and takes an int. Cool. Okay. Yep. Yeah, it makes sense. Because if we're looking at these, then sure, it'll take multiple cases, and maybe we say before, hey, this is used for this, this, and this. That's why we're using a template here. But if we specifically just want this, and we want to know what kind of function we're taking and calling, this probably makes more sense in that case. Cool. Excuse me. Use auto to prevent any conversion. Use auto, that's the ideal. And otherwise do that. Well, okay, it's just showing use these versions. Okay, cool. A generic lambda? The heck? I don't know what this is. Are we talking about like a template lambda? Oh shit. Like a function template lambda by giving it parameters that are auto? Oh, crazy. Hold on. Oh, let me do something that'll take some time. Or, well, that needs to open. Need to compress my game real quick. What's the storage looking like? Okay, we're good. Oh, and it's going to be on the other drive anyways. So we're going to do... Okay. All right. I have to go and delete some stuff from my Unreal game. Doesn't matter. I'm not going to talk about it now. Okay. These are auto for parameters. So the point is, what we could do something like, what do I want? Let's just say it prints. Okay. So no quiz, just new stuff for now. And then we'll say, what? Auto lambda print or lambda printer, and it's initialized with what? This. Okay. Empty capture clause takes a type deduced parameter and returns nothing, and we could omit that. Oops, the strat is this: tab, back, enter, enter. Okay, and then semi after the whole object is defined. Excuse me, and it's going to output X. Oh. Excuse me. Wow. What the fuck? Oh, lambda. It's a hard word to remember. Oh. Interesting. That's cool. But at some point, we're probably going to get... We'll at some point, we'll probably be like, okay, well, why don't we just have this function in a namespace somewhere? Why are we... What are we doing to this function? This poor function, this poor main function. Just thinking if I could put them in other functions too. Probably can. Cool. What is this potentially here for? It can. I mean, assuming that what the lambda can do is doable with the type that it's receiving. That's in the context of a fucking function parameter too, buddy. Okay. Const auto, same letter. Adjacent find? Search an array. It starts here and ends here. And we're searching it using a function that returns a bool. It's a lambda in this case. And it can take this, hold. So it takes an A and a B, and they're both const autoreferences, and it's returning whether the first element of A is the same as the first element in B, same value. And we finish, and we call it same letter. We say if versus same letter. And we're passing same letter months.begin, months.end. So it's going to take one element here because adjacent find hold. We're passing it a function that takes two elements, and it's going to pass in the leftmost, and then the one to the right, and then that one, and the one to the right, etc., over and over. And it's going to compare pairs, and eventually do something. If, let's see. Okay, its same letter is initialized, and it has the answer right here. It knows the one. So in this case, it's going to find June, July. So it's going to point to this guy. So it'll be pointed to the sixth element here, element 5. And it's going to check, hey, are you pointing, let's make sure you're not pointing to the end of the array, one past the last element, because if you are, that is how the standard libraries find functions say that, hey, nothing was found. They return an iterator, yes, but they just return the end iterator, which is one past. That's why, because when they're looping, they're checking, hey, are we equal to the end? Not yet? Okay, go again. Oh, now we are. Don't go. Okay. Output pointer to it, so getting the value that it's pointing to, so June, and then what? The next one? Oh, standard next is the next iterator, so pointer to the next element, likely in this case. So it'll be a pointer to June, dereferenced, and then a pointer to July, dereferenced, which is why we dereference standard next to get a pointer to July, and then we dereference it, we indirect it, we go, boom. And then we print this and this, June and July. Cool. Cool. Because if we had a specific case where the characters weren't accessible with subscripting, we wouldn't be able to use that. Or at least it would only be able to take operands that could. Good job, Oxford comma. Good job, buddy. Well, yeah, if we change auto, we're. Oh, never mind. I thought he was going to say if we change auto, then we're going to be fucked. Because if you are, oh, great. You thought it accepted all strings. Now it only accepts this. You thought that it was only accepting this. No. Okay. Oh, what's a case where we would accept something? Wait, doesn't this works with any array, doesn't it? I pass in an array to a fucking integer, and I pass it in an array to an array of integers in another one. Okay, we can take anything, so we're taking an array of integers in another one here. Okay, and we're checking, hey, is the first one of this the same as the first one of this? But really, this is an array of arrays. This is a standard array of months, but each one of these is an array of const characters. Okay, let's see. Const auto 5-letter months. COUNTIF. So I'm assuming for each one of these that is true. So from begin to end, it's not comparing now. I think it's just looking at that one. In this case, it's not taking const auto reference. It's using just a standard string view. Is the reason because if we will the compiler prevent you from doing what you can do in other functions, where you can put a function and use a member of this guy? Excuse me. If I make a function here, and I, in the function, don't know the type of the object, but I still put in dot length because I want it to handle things that have dot length and only those. I'm pretty sure that works. What the fuck? Okay. It can be array, can be a string, can be whatever. See, and it's only accepting things that have a length. So if I call print length 1, but if I call it with, actually it won't work here either because this is just a pointer to a constant character. But I could make and sure, better yet, a standard string view. Please? What the fuck is happening? What the fuck is this? Okay. Doing stuff. Hold on. And now it's cool because X has a dot length. But what if we do that in a member? Or in a lambda? Jesus Christ. If we did that here, would it be okay? I don't know. So if we do it here, maybe the point is we need to specifically say that, hey, we're accepting a standard string view, and that's why we're able to do dot length on that standard string view. Make sure this is cool. Good. Now I can fuck around with this later. Not yet. Okay. So in this case, it's going to say, it's going to check the first one, and it's going to get the length. So it's going to convert January to a standard string view, or hopefully just look at it, but it's going to convert it. And then return if its length is 5. Eventually it will for March, for not April, but it's probably going to do the first one, right? So it's just going to do the March. Oh no, it's going to count. 1, 2, 2. Okay. So using auto, if we get auto, then we're going to infer that, hey, these are, I don't know why I'm all stuffed up on the inside, are going to infer these. If we evaluate this array of const characters, we get a pointer to a const character. And if we do dot length on that, it's not going to work. Is that right? Gotcha. So the point is, one possible, the main point is already using the nice class types that the standard library provides us, because the hard work that was done to make those lets us more easily use the information, even if we have to convert it to a string view, for example, because a string view is still a class, it's still a type of string, it still just holds a reference, a const reference to some sort of, to a string somewhere, any kind, characters. But we can use dot length. We don't have to do a fucking loop and loop through until we see the null terminator, and then, oh, what happens if it's not a null terminator because you passed it something that was acceptable because of const auto, but doesn't have a terminator. What do you do? And you have to pass in the fucking length for each one of these, and you just get some stupid shit. So, okie doke. Const expression lambdas. Ooh. If they satisfy the requirements of a const expression, meaning that they can be const expression if they're callable as constant expressions, and if they don't call things that disqualify them from being constant expressions. Like mine earlier would not be a constant expression because it uses standard character output, which is an object only created at runtime, or at least only usable at runtime. No captures? And is that because if we do captures and they aren't constant expression, then we're using objects that aren't known at compile time? Therefore, if they're a const expression, then they're cool. We don't even know what captures are yet. That makes sense. It's the objects from the function that it's using. Functions called must also be callable at compile time. Okay. Excuse me. Because constant expression was made. Gotcha. Yep. Oh, we can make it a constant expression auto. Wow. And static variables? Oh, because we're saying that a generic lambda is a function template. It's just an abbreviated function template. And if we give it a static local, because a separate copy of the function template is made for each version, each instantiation, each one of them has its own variable, and we're wasting memory. Or, if we call it two separate things, we'd expect the number to be the same. Like I pass in two different enemy types to a function that's called count enemies, and it increments the static local variable for each enemy I pass it. I pass it a dragon one time. That's one version. That's one instantiation of the template function. Not the function template, but of the template function. Well, actually, it's an instantiation of the function template. Yeah, it's one version. Then, if I pass it a goblin later, and those are two separate types, those aren't just two different names of the same object called enemy, then those are only going to be counting that type that was received. Only this function is counting dragons, and this one's counting orcs because they're two separate objects. So, generic lambdas are the same. A unique one will be generated for each auto, meaning that each one of those will have that static local. So if we increment it later, we will not see the value persist. It'll look like it reset or it was different. It wasn't counting some of the info. Well, because it's two different functions. Okay, so we have one lambda saved explicitly with auto. And it takes anything. It has a static int called call count. Boom. But the point is we're going to call it with an int, and it'll print call count and increment it to 1 after we print it. So it'll be 0, and then now it's 1. And then we would call it again, and we would think it would be 1, but if I passed it with a float, it'll be... Excuse me, it'll be 0 again. Here it comes. Boom. So if I pass it hello, and then I pass it world, those are both 5 length, really 6 length, including the null terminator, strings, so we get 0 and 1. But then I print 1 and 2, we get 0 and 1 again. And if I do zing, ding dong, we get 0. 0, 1, 0, 1, and boom. Hold, wait. Oh. Okay, so it actually didn't care about the length of the string. Cool. Okay, that makes sense. Yep. There's the pointer. Well, yeah, duh, because if we evaluate any of these C-style strings, we get pointer to const character. Don't give a shit about the size. Therefore, all of those have the same argument. All of those would mean 1 instantiation. So we get 1 that's called for 0, and then 1, and then another one for the int that's called 0 and 1, and then back to the other one that's now 2. Okay. Yep. 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 And they would have to increment that one. Yep. Oh, and so the point is we could have a static in this local and then have them both capture that one and both change that one. Just like if we had created them here as a global and then change that one. But instead of them working outside the scope of the function, they just do the static local. That would be cool. Okay. Return type deduction and trailing return types. We've seen the trailing return type syntax, the dash greater than arrow operator. if it is deduced, it's deduced from the return. Fucking duh. Well, duh. For example, okay, divide, we pass in this, and that, whether we're doing division or not. Otherwise, we're doing something else. What? Oh, returning, we're passing whether we're doing int division or floating point division. So if we say true, we get 3 divided by 2, we get 1. But if we do false to get float division, cast it to a double, we get 1.5. Cool. But the problem here is that we're returning x over y, which is an int. But if we cast this to be a double, we get a we're casting x, not y, so we're dividing a double by an int, which yields a double return type, which means in one case we're returning an int return type, and another we're returning a double return type. And so the point is that we explicit casts to make the types match. So cast the int to be a double, or specify one, and the compiler do it. So if we just specify that it's going to be a double, then it will just do it. That way, even when we do the int, we still get 1. It's just 1 casted to a double to be 1.0, and standard character output will omit the trailing zeros. Okay. Okay. That's nice. You don't need to write your own because there are lambdas that already exist in functional. Oh, fuck off with functional, dude. Here, it's just going to show something. So there's probably a greater lambda. There it is, standard greater. But it's not a greater lambda. It's just a function. Callable object. Okay. Oh, I had it muted too, but all right, that's it. More lambdas. Specifically, oops, well, oh. Type deduction, templates, really generic, because we're not making explicit templates. There are no template clauses, no template type name, blah, blah, blah. No non-type template parameters. Okay. Types, return types, and generic. Okie doke.